First, we like to talk about is section 7.1. Section 7.1. This particular section is potential energy of a system. Usually, we like to talk about this isolated system. So, when you're talking about isolated system, for example, we are talking about this object living, move from here to here, and then basically you draw a box and consider this box only have this object move up and down under the influence of gravitational force. So first we like to say what is potential energy. Potential energy is called energy of position. Energies of position. Or location. So that is very important. In the what they call human society is the same way. You have position, certain position, like Obama's position. Okay, Obama's position is high. So in which case he has a lot of energy to do a lot of things. Okay, so Hillary Clinton is Clinton's wife. So at the same time, she has a lot of potential, a lot of energy to finger pointing to Clinton, to doing the work she desired to. Okay? If you don't do it, I go to media to tell everybody about Monica. Right? So immediately, she has power. So the power because and energy because the position. So in order to reach this position, you need to do the work. You need to do the work. So in this particular cases, we like to using, here is the table. Table. Have a leg here, have a leg in here. So here is a book. So we want to move forward and then up to this point. This book move to this point. Effectively, somebody moved the book up to that point, and this height move this point considering as y. Y. Okay, so effectively it has some force pushing back, in which case the force pushing back F or G. Gravitational force push back. So in order to balance it, we need some kind of work, force equivalent to F. So basically the work has to done to move it higher is equal to mg times y. That's the work. In reference to this coordinate, this is x and here is y. Okay, so that's one case to consider. Now, that means that after it move up to that location, we have storing the energy, in which case is called U. That U stands for potential energy. That means this potential energy, if somebody release this bolt, will drop. When it drops, it becomes kinetic energy. Okay. So, or we can use another point of view. Here is a table. Again, so we like to say initially the boat is in here. The boat is in here. In reference to this, the location, we like to say y sub a And I move to here, in which cases we are right to reference this equal to mg. So again, between the YA and YB, we have done some work. So work is equal to integration of f dy, in which cases from YA to Y sub B. So because we have to assume the distance relative to very small compared with the radius of the Earth, so that f is basically considered as a constant equal to mg dy from y sub a to y sub b. So basically the work is considered as y sub a. That is from some point and get to one point. So from this, basically this work done is related with changing potential energy. In which case we like to say initial potential, final potential energy minus the initial energy, initial potential energy. So in these cases, we like to say another one is what happens, what if this drop? When it drop, it will release some kinetic energy. So suppose we consider all this as isolated system. Isolated system. Under this isolated system, only have a gravitational force acting on the object, and only have the book as an object being pushed. So in these cases, then we go down to the section we call 7.2. 7.2 section. Uh, 7.2 section is important for a lot of things. It's called consider the isolated system. Isolated system. So we say draw a box around the object and the place we are interested in. So in these cases, we draw the diagram again. So that's why the diagram is very important. So we draw the diagram again, the table. By the way, if you want to study on your own, then that's why you have to keep drawing the diagram and indicate what's going on. So here is a book, and then here is a book. This is YB, and this location is YA. YA. So we'll like to say the work done on the book this time, work done on the book. The work done on the book is W on the book is equal to minus YA. That's what's going on. When you're doing this, then this work becomes kinetic energy. If this work is dropping, then it becomes change energy, kinetic energy. It drops. But if you look at the whole, when it's dropping, have no work being done because you're holding it, no work being done. So you like to write down the energy changes because of the work done. So basically is